A great day to one and all. I am Kim J. Ensho, and today I bring to you problem 11. The coordinates of the vertices of a triangle are 5, 1, 11, 1, and 11, 9. Find the coordinates of the circumcenter of the triangle. Please pause the video, give this problem a try, and if you are ready, resume playing the video. And before I reveal the solution and answer to this problem, a special shout out to Techno Guy GameGod for suggesting our problem for today. Before I divulge the problem as well, it's important that we know the concept of a circumcenter. Suppose you are given a triangle ABC. Let us locate the midpoints D, E, and F of all the sides. Say you have this triangle here. And since D, E, and F are midpoints, and by definition, a midpoint divides a certain segment into two equal parts. So we could say that these segments here, having the same number of tick marks, are congruent to one another. Let us draw certain segments that pass through these midpoints and that these segments are perpendicular to the sides. So it would look like this. If you could see, it appears that the three segments intersect at a point. Let's call this point G. And it is in fact a theorem that the three perpendicular bisectors of any triangle intersect at a point. And this point of intersection is what we call circumcenter. So here, it's exemplified by point G. Let us connect as well using segments point G to each of the vertices. So if this happens, so we have here segment GA, segment GB, and segment GC. It is also important to note that the point G or the circumcenter is in fact equidistant to all of the three vertices. That is, segment GA equals segment GB equals segment GC, and each of these three segments in red serve as the circumradius of circle G. Also, circle G is what we call the circumcircle of triangle ABC. So that is for a simple concept check and review for the definition of circumcenter, because it's necessary for us to understand the solution to this problem. And it's also important to see that these points here, A, B, C, could actually serve as the 3 points on the circle, and this circle is your circumcircle. Now, I will be revealing two solutions for this. Let's say the first solution would entail that we have to plot the 3 points and draw the triangle. So using GeoGebra, we could actually see that they form a right triangle. And how do we know? If we could see segment AB here have different X coordinates, but has the same Y coordinates. So this implies that AB is a horizontal segment. Also, for segment CB, their abscissas are equal, but their ordinates or Y coordinates are different. And this means that CB here is a vertical segment. And it's in fact a true statement that a horizontal and a vertical segment in a coordinate plane are perpendicular with respect to their point of intersection. So we could say that angle B is a right angle. And since triangle ABC has a right angle or a 90-degree angle, then triangle ABC is a right triangle. And another concept check for right triangles is that the coordinates of the circumcenter of a right triangle are the coordinates of the midpoint of our hypotenuse. When we speak about hypotenuse, it is the longest side of your right triangle. And this is in fact the side opposite your right angle. So it's your hypotenuse here is line segment AC. And to solve for the circumcenter, we have to solve for the midpoint of segment AC. To solve for the midpoint of 2 points A and C here, let's say if points A has coordinates x sub 1, y sub 1, and point C has coordinates x sub 2, y sub 2, then we use the formula for midpoint, that is, the abscissa of the midpoint is the mean of the x coordinates, and the ordinate of the midpoint is the mean of y sub 1 and y sub 2. So with our x sub 1, y sub 1, we have x sub 1 is 5 and y sub 1 is 1. With our x sub 2 equals 11 and y sub 2 equals 9. And by substitution, so we have 5 plus 11 all over 2, comma, 1 plus 9 all over 2. So 5 plus 11 simplifies to 16. 1 plus 9 simplifies to 10, and the rest were just copied. 16 over 2 is 8. 10 over 2 is 5. Hence, the coordinates of the midpoint are 8, 5, and that the circumcenter of the triangle has coordinates 8, 5, which is somewhere here. And in fact, if we plot the point 85 here, and using GeoGebra, we could see that the midpoint of your hypotenuse AC, which is point D, 85, is in fact equidistant to the 3 points. By using GeoGebra, AD is 5 points, DB is 5 points, or 5 units rather, sorry for that, and DC is also 5 units. You could utilize the distance formula to verify 5 units. So hence 8, 5 indeed are the real coordinates of the circumcenter. And for the simple fact that it's equidistant to all of the 3 vertices here. That's another way of showing that. And aside from this solution, we can also utilize a method that makes use of the distance formula. Let's say, and this concept is useful regardless if your triangle is right or not. Let's say I arbitrarily located here the coordinates of our circumcenter for now. Let's say it's this. If the point D with coordinates xy is the circumcenter of triangle ABC, then as what I mentioned earlier, then DA, DB, and DC should be congruent. And how do we know if they have equal lengths? By using the distance formula, which probably many of us learned in our 10th grade, depending on our location. And the distance formula is, if you have 2 points, x sub 1, y sub 1, and x sub 2, y sub 2, then D is equal to the square root of the quantity, the square of the difference of x sub 2 minus x sub 1, added by the square of the difference of y sub 2 and y sub 1. Similarly, if we square both sides of our equation, so the square of D is D squared, equals, if you square the expression on the right-hand side, it will just be the same. It's just that there's no more radical sign here. So D squared equals x sub 2 minus x sub 1 quantity squared plus the square of the quantity y sub 2 minus y sub 1. From here, we could actually see that if we use this formula, if we are looking for distance dA, let's say D and A, we have, by substitution, that's x minus 5 quantity squared plus y minus 1 quantity squared equals d squared. We let this as d squared here because we don't know yet what the distance is. And besides, I also utilized the symmetric property of equality to arrive to this equation. If you have distance dB, these two, then that's x minus 11 quantity squared plus y minus 1 quantity squared equals d squared as well. And as what I mentioned earlier, dA should be equal to dB because it's equidistant to all of the vertices. And by equating, therefore, since both of these are equal to d squared, then there is a sufficient reason to equate x minus 5 quantity squared plus y minus 1 quantity squared with x minus 11 quantity squared plus y minus 1 quantity squared. And you could see here that y minus 1 quantity squared is common to both sides. So we can subtract both by y minus 1 quantity squared. And that gives us x minus 5 quantity squared equals x minus 11 quantity squared. Squaring both sides of the equation, the square of x minus 5 is x squared minus 10x plus 25. And the square of the right-hand side is x squared minus 22x plus 121. If you wish, you could actually review how to square a binomial, or you may do the FOIL method as you wish. X squared is a common term both sides, so subtracting both sides by x squared, so that will be gone. Also, I added both sides by 22x, so the negative 10x plus 22x becomes 12x here. Also, I subtracted both sides by 25, so this one becomes minus here, and 121 minus 25 is 96. So if 12x equals 96, then dividing both sides by 12, we could see that x is equal to 8, which is now the abscissa of our circumcenter. And now, let us find the ordinate of our circumcenter. So using still the similar process, I will now focus on dB and dC here. So for distance dB, that was already given earlier using the formula. For distance of DC, of this segment DC, by substitution, we have here x minus 11 quantity squared plus y minus 9 quantity squared equals d squared. And again, with dB equals dC, and since both of them are equal to d squared, therefore it is okay to equate their left-hand sides. That is, you arrive to x minus 11 quantity squared plus y minus 1 quantity squared equals x minus 11 quantity squared plus y minus 9 quantity squared. All right. And we could see that x minus 11 quantity squared is a common term for both sides. So we can subtract both by x minus 11 quantity squared, and that gives us y minus 1 quantity squared equals y minus 9 quantity squared. From here, we can square now both sides. We can square now each of the binomials, and that gives y squared minus 2x plus 1 equals y squared minus 18x plus 81. Y squared could be subtracted both sides as well. If you add 18x both sides, so negative 2x here, it will be plus 18x. That's 16y. Sorry, it should be y. This should be y. And also, if, and from here, This one will be subtracted on the right-hand side. So 81 minus 1 is 80. And we have 16y equals 80. Dividing both sides by 16, we have 80 divided by 16, which is 5. So the y coordinate of our circumcenter is 5. Hence, the circumcenter, combining them into a single point, our x earlier was 8 and our y is 5. So the circumcenter has coordinates 8, 5. There are many other possible solutions for this, and you are free to comment them here below. And if you know of a better solution, feel free also to message me or comment in our chat box. And remember, you are free to suggest a problem at my Messenger and Facebook accounts, Kim J. Ensho, or at my email, kimj.ensho@iloilo.nhs.edu.ph. And before I end, let us remember, in the hills of sacrifices lie the valley of success. With that, TYBM, thank you very much, and a great day to one and all.